I'm going to just give a quick intro. We have all 5 of our speakers. I'll tell you right off the bat, I've never done a flash session. I've moderated many, many sessions, never done one of these before, so it's going to be interesting. Yeah, so that's why I'm starting my little spiel early. So each speaker will have 5 minutes. I understand that the next session is lacking speakers, so I've been told that we have a little more time than we otherwise would. If we want to go a little bit longer with questions, I'm not going to stop anybody from asking them. I realize that 5 minutes is not a lot of time to present a significant amount of information, so there may be quite a few questions. We'll go ahead and entertain those as they come up. So I have a phone. I'm going to set it at 5 minutes. You'll hear it ring, okay? And that'll tell you you're done with your 5 minutes. And then hopefully you're done. So our first speaker is Risalat, Rafiq, and he's going to speak about the key hydrochemical processes immobilizing trace elements, arsenic, iron, manganese in ISMAR for drinking water provision in Bangladesh.
Good to go. Good afternoon. My name is Risalat Rafiq, and I'm doing PhD at TU Delft about groundwater quality assessment in ISMAR system Bangladesh. For next 5 minutes, I'm going to discuss about how trace metals are mobilized in ISMAR system Bangladesh with push-pull test findings. In Bangladesh, fresh surface water from pond is injected with infiltration well in the anoxic brackish groundwater. And during injection of pond water, oxygen and in some extent, organic matter is introduced to the anoxic environment. That might trigger either pyrite oxidation or iron reduction. As a result, elevated arsenic has observed at some ISMAR sites. Therefore, we want to know about the mechanism behind trace metal like arsenic, iron mobilization in ISMAR system Bangladesh. So what is push-pull test? A typical push-pull test involves the injection of a prepared test solution into the subsurface at a single location and followed by extraction of the test solution and mixture of groundwater from the same location. The injected water mixes with groundwater by dispersion, and the part of tracer and injected additives can be found till twice of injected volumes. And what we can obtain from push-pull test is change in chemistry as a function of time. We measured certain elements, and the concentration is plotted against the ratio of volume abstraction over injection. Here, the chloride concentration shows the dispersion from the lower injected water conductivity to the higher groundwater conductivity. For better understanding the processes, the fraction of chloride is calculated based on the injection and groundwater values and plotted as a green line. If only the physical mixing would occur, not any biochemical reaction during push-pull test, then the black line should follow the green line. Otherwise, anything below and above the green line should be considered as a process. We started injecting water with fully aerated water that contains oxygen, around 8 milligrams per liter. And oxygen has consumed rapidly compared to the green line. As a consequence of rapid consumption of oxygen, we can expect increase of sulfate around 13 milligrams per liter from the above equation. But in our case, the sulfate increase is very minute. This is also similar for bicarbonate. Additionally, the rapid consumption of oxygen can be explained by the oxidation of dissolved iron in groundwater, and thus the sorption of iron arsenic and also manganese has observed from this graph compared to the green mixing line. We applied another push-pull test that is with anoxic water adding sucrose, and we observed that after 15 hours from injection, rapid increase of iron, arsenic, and manganese. With combining these two push-pull tests, we can conclude that the oxygen leads the oxidation of dissolved iron, and the formation of iron oxide lead the removal of trace metal like arsenic, manganese, and iron. In other cases, the strong increase of iron, manganese, and arsenic were observed with anaerobic sucrose addition push-pull test. There are some outlooks. The results presented here is the part of my research is not inclusive, and the geochemical analysis with sediment samples is under processing, so that will validate the current push-pull test findings. So what we can take home with us, make the freshwater bubble more oxic, might lead the immobilization of trace metal at ISMAR site in Bangladesh. I think that's all. It's too quick to finish.
Thank you. Very interesting talk. We have any questions?
Yeah.
Yes, thank you. Very interesting, the second presentation on the push-pull tests. So I think it's a nice rapid technology.
Yeah.
But made me curious here because it's so rapid, and I'm not sure, but I can imagine that you also have a long storage period. Is there a big risk that you miss processes that occur during a long storage period? So you make the water more oxic. That's an option to do. But in a storage period, is there a risk that it becomes anoxic and that you get remobilization again? Knowing the site, do you know if there's a risk?
In the second push-pull test, it's true that it can be happen, but I am now processing the data and looking forward to your next step that it is going to be again immobilize the arsenic or not.
What are the storage times, more or less?
I did it for a very quick time, like 3 or 4 days.
Mm-hmm. And in the situation on the larger scale?
No, in a smaller scale.
But what is it at the ASR scale? The systems they use? There are a few of them already.
Yeah,
then it's months or?
It's kind of storage, transfer, and recovery in the same time.
Okay,
so people put injected water and abstractor in the same time.
Okay, rapidly.
Rapidly,
Okay.
yeah, simultaneously.
Thank you.
Thank you very much.
Yeah, thanks.